Okay, do you see my screen again?
Title slide.
Okay, now let me change to the next slide. Do you see the next slide now?
Yes, now I see your cool slide.
Okay, I'm glad that our deal is over. I am still Ryan Kellerman after all of that. Where did I leave off? Yeah, my PowerShell scripting seems to be a little more almost application-like in nature, the scripting I do, and a little less sysadmin-y in nature. So that being said, I'm not a fan of pipelining. I don't do a whole lot of it. Yet PowerShell 7 is going to force me to talk about it a little bit. So wish me luck. So for this talk, I'm going to go through kind of the roadmap of where we've been with PowerShell and where PowerShell is headed. Quickly review installing PowerShell 7. Talk about some in particular new things in compatibility with PowerShell 7, and then get in, as like alluded to, some of the new coding tricks you can use if you are using PowerShell 7. All right. So that being said, here's a little roadmap documented myself. So I think of PowerShell as kind of a two-lane highway going in the same direction. We have the PowerShell native releases, which are kind of the traditional desktop-based PowerShells that go back to Windows 2008/2003 R2. I think you could get away with installing older versions of Windows if you necessarily had to. I think, Frank, you're the expert there. So there's the native side of things, and then there's the core series of PowerShell, which was introduced in January of 2017. PowerShell 7 is a technical and spiritual successor to the PowerShell core side of things. It drops core in the moniker for the product name, but it still shares a lot of the features of PowerShell core. That is, it's based on .NET Core, like PowerShell core was, instead of being based on the .NET frameworks like the native lane of PowerShell was. It uses pwsh.exe as the binary for the shell, as opposed to PowerShell.exe like on the native side. Also, the big advantage of PowerShell 7 is it can run in a heck of a lot more places than you are capable of running PowerShell native. PowerShell natively was kind of closed source and was stuck in the Windows world. The PowerShell core side of things, you can have it running on Mac OS, Linux, ARM systems, all sorts of fancy pants things. One of the issues with running PowerShell 6 core, 6.2 and older was that there were compatibility problems between running PowerShell scripts and code that you ran for the native PowerShell versus the core series. It's reported at this point there's about 85% of the native functionality of PowerShell native has been built in through modules and other processes into PowerShell core. So getting closer and closer to that idealized state. Microsoft is continuing to do development work in that direction, getting us closer and closer to parity entirely of the native features being available on the core releases. The way PowerShell is being released and updated now is changing as well. PowerShell is moving into an annual cadence, so we can expect annual releases of PowerShell core going forward, which also leads us into the familiar world of having long-term servicing releases. So PowerShell 7 is actually an LTS release, and it will be supported at least through March of 2022, based on 3 years after the release of March 2020. So that being said, I want to make sure I haven't missed anything here on the PowerShell roadmap. I wasn't able to dig up a lot in terms of what the new features or capabilities are going to be down the road, other than kind of like closing that compatibility gap. So let's talk. Oh, one other thing. To know whether or not you're in PowerShell core native from a scripting perspective, the PS version table can be used to report whether you're a core or a desktop, which is what I'm referring to as the native versions based on the .NET frameworks of PowerShell. So if you need a property to identify what you're running under, that's how you do it, which, as you had mentioned previously, Frank, which works for all versions of PowerShell except for the initial release, which didn't have the PS version table available. So installing PowerShell 7, there is a lot going on here. So kind of a, for us traditional, for me on the traditional Windows side in use, I can go out to aka.ms/git-PowerShell and download the latest release. It's just a shortcut link over to the GitHub page where I can get the releases. You can use a PowerShell script that uses that URL to just go ahead and execute that MSI by downloading it straight and installing PowerShell 7 onto your system. One thing to note when you install PowerShell 7 on a system, that a Windows system that is already running PowerShell Core 6, PowerShell 7 will replace that. It will not, however, replace the PowerShell, that native lane of the desktop edition of PowerShell. That's, the PowerShell.exe binary will remain untouched, and the pwsh.exe binary file gets updated. So I mentioned core PowerShell is available on other platforms. You can run it on distributions of Linux. I have the commands here in the deck for presentation. They're available from repositories directly. I think Debian distributions and their derivatives are easier. Just sudo apt-get install -y PowerShell, easy peasy. Red Hat derivative distributions a little bit more complicated. You got heck of a package name there to remember for the RPM file. You don't have to necessarily go through repositories. Also, you can externally download debs and RPMs and deploy to operating systems that way in a Linux heavy environment. If you are running macOS 10.12 or higher, you can use brew to install PowerShell on your Macintosh operating systems. And then, Docker installations, Docker pull, you can pull directly from a repository, but pull an image that has PowerShell in it already. And Frank, it is escaping me what you had said about latest being not available. Oh,
that comment doesn't apply to PowerShell, but in general, using Docker and not specifying a image, a lot of times it will fail because people don't manage the latest tag, and PowerShell does, so kudos to them.
And then the last one here, and I'm going to backtrack here a little on my, oh, apparently my house is on fire. Somebody's got something out of control in the kitchen if you hear the beeping in the background.
Hopefully that's not a real alarm or not a real problem.
I doubt it is. It's probably some burnt chicken nuggets or something. No serious emergency. The losses are very real, but we will try to power through it, I'm sure. Mostly for the developers in the house, you can use the .NET SDK tool-based installation of PowerShell, which will allow you to run multiple versions of PowerShell core to do a user profile only installation of PowerShell for use for that development user. When installing PowerShell 7 on Windows 10, it is a very similar process to installing PowerShell Core 6. You have the same 4 installation options, which is to add the pwsh.exe file as an environment variable to the system. You can register Windows event log manifest for events coming out of PowerShell 7. Enable PowerShell remoting for PowerShell 7 onto the local system you're installing PowerShell 7 onto. And then good old right-click context menus in Windows Explorer, so you can launch PowerShell 7 from anywhere in a folder hierarchy, such that the shell will be launched into that path of PowerShell 7. And like I mentioned earlier, installing PowerShell 7 will do things to PowerShell Core 6, but it will not change the Windows native lane, modify PowerShell based on the .NET framework in any way. So some of the newest or important things, in my opinion, is how compatibility works between PowerShell Core 7 and the native lane of PowerShell. Microsoft is taking great pains, is making efforts to kind of bridge the gaps between the core lane and the native lane. In my opinion, in the limited testing I've done over the last 6 weeks running some PowerShell scripts in PowerShell 7, the compatibility seems to be pretty effectively invisible. There are the abilities for you as the person running a PowerShell script or authoring PowerShell scripts to modify or change that behavior. You can force the compatibility layers to operate or force them off if you so desire. So you can kind of control that behavior. Out of the box, most modules just work in PowerShell 7 or have been ported over to PowerShell 7 on the core side of things. But the three specifically excluded are PS Schedule Job, best practices, and update services. Outside of that, another important thing to note, you must have Windows PowerShell 5.1, that native lane, installed at that version on a system with PowerShell 7 for that compatibility layer to function. Otherwise, the components it needs to do the compatibility for running older scripts effectively will not be in place. Other things to note about that, only works locally on Windows computers for that compatibility. So, be aware of what's going on if you're doing remote script execution. The compatibility only works on serialized commandlet parameters. So the parallelization stuff that we'll get into later, not so much. And then all of the modules imported into Windows PowerShell remoting sessions must run in the same run space. So let's get into kind of the real fun stuff, which is the new tricks and the new coding capabilities that PowerShell 7 brings to the table. So I put these in what are my opinion of the most interesting to the least interesting. I think the most useful, powerful enhancement is adding a parallel switch to the for each object in PowerShell. So when you do a for each loop on a collection of items, and in my example here, I'm doing it against a collection of computer names that I filtered out of Active Directory, which I think is common for a common type task for a lot of system administrators if they're deploying a change that requires a script or inventorying system, gathering system information. Really kind of a handy thing to do. Well, in my lab environment doing some testing with this, I was just reading the release ID out of a registry key on all of these remote systems. Well, I probably is true in many Active Directory enterprise environments, have a lot of computer accounts inside of Active Directory that are for machines that are powered off, are behind a more restrictive Windows firewall. Maybe they're not valid machine accounts anymore and the machine's been powered off long gone and nobody's done any of the cleanup on those machines, which causes a serial operation like this to basically time out on a lot of systems. So my lab environment's probably 25 computer accounts with actually like 17 servers and workstations running in it. Running this without the parallel command took about 5 minutes for all of the failures that needed to happen, interstitially between successfully gathering data on systems. Whereas when I ran in parallel, I could get through my errors a lot faster. And it took my execution time from 5 minutes down to under a minute, which was pretty damn spectacular in my opinion. I like it when things like that run a lot faster. And between the two the two command lines here, the only changes I made between these commands in the PowerShell 7 versus the native is highlighted in those yellow boxes there. So after for each, I added a dash parallel option, and then I established a throttle limit with 10 parallel threads working at a time going through the loop. But outside of that, there's really very little code change you have to do to make this work. And because of the compatibility layers that are made available in PowerShell 7, I'm doing native Windows 10 type operations here without issue in PowerShell Core. So in my opinion, pretty neat stuff. And I like that the native version of PowerShell is still advertising to me when I launch it that PS Core 6 is available. Okay. The next neat kind of thing is the ternary operator, which was introduced with PowerShell 7. So a lot of us who have done, flow control and are used to using the curly braces to flow control code, doing an if, else, then statement takes 5 lines of code effectively. If you have tight, compact, like conditional for the if, and you don't have, large, complicated commands that you are passing through in the event that it's true, or the else in the case that it's false, it makes a lot of sense to use this ternary operator. You can condense that code, basically you can think of it as like a 2-item switch block, if you will, into a single line of code. So it makes your coding a little more compact. I just personally try to avoid if the code that runs conditionally is a little too unwieldy. It makes it harder to see what's going on. For cleanliness, we'll still use the older curly brace bracketed format. But if you're the kind of person who likes to write shells that are obfuscated and hard to follow, and you feel like a better person because you are superior to other PowerShell coders, and more power to you. This is a new trick up your sleeve to make things harder to read. Another handy new feature is improved error message display in PowerShell 7. So this is when you are running a script file. So I created a little sample script called Script of Doom, which is designed to fail and generate an error message. You can see the old format. Everything's basically monochrome of a single color on an all black background, and you have to really work as a human being to visually parse what this error message is telling you. On that second line of the error message there, you can see that it doesn't even tell you it's line 1, but it's line 1, character 1 is where the error occurred. Whereas you look at the PowerShell 7, where I ran the same script and it failed, you see the same exact error message. Is a heck of a lot easier to, as a human being, to kind of parse what's going on. You can see the line where the error is, and then you get the nice tildes underlining to where the actual what the actual commandlet was that produced the error. And then the error message itself is pretty pretty much straight out there in front of you. Cannot find the C:/existence is meaningless as a path because it does not exist. Huge improvement in my opinion. And especially when you have scripts and lots of errors are flying out of it. The old way just looks like just a lumpy mass of error messages. It's hard to discern what's going on unless you really have sit down and concentrate and use the human mind to parse what's coming out of it. The last one is that I'm covering here, and because you just can't overlook this, even though I'm probably not personally likely to use it, is conditionally chaining pipelines. So, oh, there it goes again. Kitchen's on fire again. Have the two new operators here. So the double ampersand and the double pipe. They are complements to one another. Basically, when you have on the left-hand side a command, these operators dictate what happens on the with the command on the right-hand side. So based on whether or not there's a success or failure, whether or not there's an error message on the initial command on the left-hand side, different behaviors happen. So I have a table here that's kind of tries to lay out the logic of it. So the double ampersand basically says, do something if this completes successfully. So if the left-hand command is successful, something happens. If it's not successful, nothing will happen. And the double pipeline operator does exactly the opposite. So if you are successful, then everybody goes home quiet, nothing happens. And then if it fails, then it'll actually invoke the right command and something will happen. So that's, I think it's a little hard to follow what I'm explaining there. So I kind of ran a interactive shell script to kind of demonstrate what's going on. So if you look at the first line of the screenshot I took here of my PowerShell 7 window, I did get execution policy and then the double ampersand operator, and then just a straight up the string of yay with an exclamation point. with the double ampersand, if it's successful, that means it's going to do what's on the right-hand side. So in this case, get execution policy returns remote sign because that's what the execution policy is on my local system. And because that was successful, there were no error messages. It goes ahead and dumps the string into the command line. Yay! So that's what you see there. In the second command line, which I'm kind of pointing to here with my mouse pointer. Oh wait, over here on the screen, pointing to with my mouse pointer. The get dash nothing is not a valid PowerShell commandlet. So that's going to produce an error message, and then dump, if in the event that it's successful, it's supposed to dump the text boo to the command line. So you can see you get the big fat red error message that comes from running a commandlet that does not exist, and nothing happens then, so you don't see boo on screen. And then below that, so we get to our third line, demonstrating the opposite behavior. So in the event that your left-hand command is successful, the right-hand command is not supposed to execute. And that's what happens here. So we do get execution policy. Again, it returns successfully, remote signed. That's the execution policy on my local system. And because that was successful, the right-hand option, the expression does not get processed. So we only see the remote signed output. We don't see the yay string output. And then conversely, intentionally break it again by calling a bad commandlet. So get dash nothing. Again, it's invalid, so we get this big error message, and because it failed, it goes on then to process the right-hand side. So we see here the text boo is actually dumped to the screen. So kind of a nifty little operators to save doing some conditionals. It's built right into the pipeline handling there. The other items here, oh, there's a lot of white space in the middle there. Questioning my design decisions in real time. So no coalescing operators. Basically what these two operators do is make handling instances where a variable is null, or it contains null data, to that is no data at all, to make things happen without having to handle errors or do any kind of function to test whether or not the object contains data. So null coalescing only processes the right operator if the left expression is null. So I take the following: I have $variable is my variable, and then I've got my double question mark operator, and then I threw pi in there, 3.1415926. If variable is null, what's going to happen is it's actually going to then proceed to execute the right-hand side and return an output of the string I put in there, 3.1415926. And then if the value contains a value, then the value itself, so whatever's contained inside a variable, will be returned as output. So that kind of just dumps things to the pipeline, to the console for you. The null coalescing assignment, the double question marks with an equal sign after it operator, actually does behave similarly, but accomplishes something in the same time. It will assign it will assign a value to the variable if it's null. So again, I have my $variable, question mark equals, and then 3.1415926. If the variable is null, then what's going to happen in this scenario is the variable is going to be assigned the value of 3.1415926. Nothing will be output to screen. Your variable will now contain that value. If the variable contains a value, then the variable's value is unchanged, so nothing basically happens. So it's just a nice way of handling null conditions in your variables when you're writing code. Oh, I meant to take that test connection out and I forgot. Miscellaneous new items. So a couple other things that were really low on, in the interest level for me personally. So they just get crammed into a slide together here. PowerShell 7 will check daily for updates. It will notify operators if there's updates available. This behavior can be modified, but I don't know why you'd want to do it. Everybody wants the latest and greatest, I'm sure. I'm going to skip over test connection. Start job now behaves a little differently. It now sets a default working directory to the current path location, instead of using the previous defaults like its old behavior would be. And then the PS culture variable now, if you change that in session, changes to what it's set in session. So if you change your region, whatnot, that behavior is different than older versions. So just something to look out for if that's something you're doing code-wise previously. So I didn't pay attention to how I was doing on time, but I think I'm okay. So really overall, the roadmap for PowerShell 7 is, Microsoft is working on making core behave more like the native. It's converging those work streams. It's core inherently has, greater compatibility with other operating systems and hardware. And we'll get into, Frank will get into some of that later. And then there are so many options with the core derivatives of PowerShell. You can install this thing in so many places and run it in so many places. It's looks like Microsoft's positioning this thing to take over the entire world. And then, I think depending how if you feel differently about pipelines than I do, the new tricks built into the shell may or may not be valuable to you. But per usual, I think Amanda was saying that if you have any questions, direct them to her directly if you can. It makes it a little easier for her to parse what's a question for me instead of a posting it to all, where the pandemonium, I guess, can reign. I don't even have Zoom up right now, so I can't see that. Any questions?
Yes, we have a question. How has real-world use of the for each object parallel switch improved performance? Have you compared it to thread jobs or run spaces?
I don't know other than than to say from my personal experience when I use it, it's improved performance just because doing in testing a sysadmin type task, the thing failed a lot faster. And when I have timeout scenarios where I have to wait 30 seconds for a connection to fail, my system's not busy, it's not eating up a lot of CPU time. So to parallel, getting to the fail state faster or to whatever the invalid is, it improved performance. But I haven't done any testing to compare, different run spaces and things like that.
I haven't either, Ryan, but my understanding is they're about the same. It's just that those take a lot more setup expertise and time.
That's what I was going to say is the thing I like about this is it's just a switch. It was dead simple to put it in place. And it was like, there's no serious refactoring of code to make this thing happen. You just slip this two switches in and you're on your way. And actually you don't even have to set your thread count. You can just let it, operate on defaults. So I think that's the biggest win for it.
And we have another question. When installing PowerShell 7, do you know which of the installation options are the default?
My recollection is I'd have to go dig up the screenshots I took of it, but it was the first two options were checked by default. I'm going to go back in my deck to that slide. So my recollection was that the add PowerShell to path environment variable was checked and the register Windows event logging manifest were checked. But please don't quote me on that. That's just what my recollection is. I almost put screenshots in here of that. I should have. That would have answered that question. Any other questions?
I think that was it for this session.
I see this as an absolute win. I'm done.
Awesome.